Zoop, zoop. Guys, we did this yesterday, right? Guess what? I'm showing you how close we are to being done. And then what did I say you get to skip? Oh, but it was so fun. Look at all the slides. Okay. Okay. All right, so we're going to get back to this, but do we really have to take tons of time on this? No. So if we get through homework questions quickly, which I still want to answer as much and as many as you have, because partial fractions can get weird. But if we have extra time, that's why I'm fully expecting us to work on some homework. Sound good? Okay. So let's go ahead and, if I can get to section 7.4, there he is. I'm also going to open up the chapter 7 homework sheet so that when we do finish, you guys, or I'll be ready to show you guys either the review or chapter 7 homework, whatever is more applicable for you guys. All right, here we go. Colored pens at the ready. Zoop, zoop. Uh-oh, why is it there? Okay, number 2, improper. Number 2, improper. Number 6 and 8 and 14, I think you were just matching, right? Just to the form. You didn't even have to solve. P.S. On the test, there could be some problems where you're only having to get the forms. But if you don't look at the multiple choice and see the A and the B and the C and you spend all that time solving, would that be really sad? Okay, so just keep an eye. If you only need to set it up and don't need to solve all the way, well, just keep an eye open on the test for looking at the answers. Oh, I just have to set it up. Cool. Done. Move on. But other ones, yes, you will have to solve for. So 6 matches with C, 8 matches with A, 14 wasn't matching, but it was writing it out. Did you guys do what we told you to and count up to the 4th degree? Good. And why is it just A and B and C and D? Because what's on the inside? Yeah, no squares on the inside. They're just linear on the inside. So just A and B and C and D. Number 22. It wasn't enough to set it up, was it? But did anybody figure out this was as easy as doing the thumb trick? Now maybe you solved it the long way. Totally fine. You should have gotten the same answers of, pause and look, 4/5 and 1/5. But can we review really quickly the thumb trick method? Because how many of you guys used the thumb trick on this one? Like you realized it and you used it. That's it? Oh, you guys loved the thumb trick. Only 2 of you? Okay, hold on. Wait. It's not as hard as you think. Remember? Weren't you supposed to factor right away? Why are we allowed to use the thumb trick? Yeah, it's a nice easy one. No squareds on the outside, no powers on the outside, and no squareds on the inside. This is prime for thumb trick. So remind me of the thumb trick. Someone, anyone. Michael. Okay. Which is? Good. So what was 3 plus 1? What's 3 plus 2? Done. Oh, remember you liked that one. Some of you were maybe absent when we did it, but most of you liked it, right? Now, sadly, it's only easy on the easiest ones, but that kind of makes sense. Okay, then, Lainey, how do you finish it? Because you also did the thumb trick. Mm-hmm. Good. So what's negative 2 plus 1? Negative 1. And negative 2 minus 5? Oh, sorry, minus 3? And what's negative 1 over negative 5? Done. Now, remember the book writes it weird, and we did an example just like it in class, because some of you might have written this as 4/5 over x minus 3 plus 1/5. Were you wrong? No. But what did the book do? It said, oh, look, there's little fifths that's in common, that are in common. What did they do with that little fifth? They pulled it out. That's it. Done, done, done. Do we have the thumb trick? Yes. When can we use it? No squareds in and no squareds out. Does that make sense? Squareds or cubes or anything else. No squareds or cubes or anything else in or out. Make sense? Christine. It'd be great just if it's a multiple choice. Make sure you can match it. Does that make sense? Whoo! Whoo! It's okay. We did ones that were worse on it in our examples in our notes. But I better zoom in. I know as an owl for a second that was weird. And now the recorder picked me up quite well, being an owl. I'm trying to zoom in a little bit. There we go. Kiddos. Kiddos. Don't even worry. Don't even worry about what the book did to rewrite it. Don't even worry about that. Just look. Did anybody get negative 1, 6, 1, 6, 1/3, and maybe in a different order, because maybe you wrote these in a different order? Did anybody get there? Oh. Where did we get stuck? Everywhere? Okay. Some of you got stuck right here. I'm going to go ahead and get off the screen because some of you are frantically writing, and that is not the point, right? The point is you know how to do it. So hold on. We get it. We get it. I get it. Most of you already got it. That this one was hard. Okay, so what number was it? Okay, how many of you knew coming into today's class that you had a question on 36? That's it? So the rest of you that didn't get it and didn't have a question, I'm a little confused. What's going on? So who didn't know it coming in? Should be almost everyone, right? And the rest of you guys were like, well, I didn't even do, that's a whole other problem, right? Okay, 36. Don't get stressed by the answer key. Look at the problem and see where you got stuck. And some of you, I know, it was right at the beginning because what did they give you down here? X to the? Ooh. Then what? Okay, I get it. Some of you got stuck right there. It doesn't mean you couldn't have done it. Just let's figure out how to keep going. What's in the numerator? Oh, alone? Okay. We can't pull out anybody in common, right? But the weird thing is there's no cubed and there's no x term. It kind of looks like a trinomial, yeah? Huh. I wonder if it really is a trinomial. Is that a thing? So, could we make this? No, wait. Would it be x minus 4 and x plus 2? Because there's no number in front. Remember, just jump straight to the factors. Is it x minus 4 and x plus 2? It's x squared minus 4. And x squared, bless you. Because check it. Wouldn't this be x to the 4th? And wouldn't these be x squareds? Then wouldn't that be a number? Jacob. Yeah. Actually, the fact that there's no x and x cubed made it so that's exactly what we wanted to do. If there was an x and an x cubed, we'd have to start doing like synthetic division and trying to do that polynomial division to find little baby factors one at a time, like way back when. So if there are lots of terms, that's where it gets messy. But since it is a trinomial, and we have a nice x to the 4th and his square root, x squared, it was primed and ready to go. But I understand why you were, because most people see the 4th and they're like, oh, I can't do what I want to do. But since there are just 3 terms, a squared term, because it's x squared squared, a regular term, just x squared, and a constant, it was primed and ready to go. But thanks for bringing that up, because you're right. Most kids look at that and say, oh, it's an x to the 4th. But we could totally factor it. Now, guys, hold on. We want to factor it all the way. Which of these factors can't we factor? Totally illegal. It's going to be imaginary. Good. Can't. That one's stuck. It's one of those irreducible. We saw those yesterday. Okay, but what can we do with this guy? Why am I writing 3? What can we do with that guy? He has a minus. He's allowed to be factored. What's x squared minus 4 factored? Oh, I did it in the wrong order. But yeah, x minus 2, x plus 2, x plus 2, x minus 2. True? Okay. How many partial fractions? Oh, I already showed them. 3. Who are my denominators? We have a little extra time. If you're here in your homework, keep going. Ew, fractions. You know what to do. Keep going. If you haven't gotten here in your homework, fine. Back of your spirals. You have a workspace. Do this problem now. Either you're in your homework or you're in the back of your spirals. Do this problem now. If you do it now, you'll have it done for later. And you don't need to watch me do it. You just needed to get going on it. That's okay. That's okay. When you first learned how to ride a bike, as long as you've learned how to ride a bike, didn't somebody hold on to it for a little bit first, usually, when you were going to just 2 wheels? They just said, here's a bike, have fun, bye? Everyone did not do that. Okay, if you are going to teach your kids someday how to ride a bike, or your nieces and nephews if you don't want kids, either way, or you're adopted because you don't want to take them home at night, whatever. Like you adopt someone else's family and you're like the cool aunt who's just not having to do the rest. Coming back, if you care about a kid someday and want to teach them how to ride a bike, are you going to say, here's a bike, go have fun? If you have a heart, what are you going to do? How? You do it a lot and then just be like, go. Just give them lots of positive words and then they'll know how to do it? Hold them steady a little bit when you take off the training wheels, right? Hold them steady a little bit, get them going, but eventually what are you going to have to do? I'm letting you go. Go. Good thing you're not parents right this second. Praise the Lord. Here we go. But once again, you can be the cool aunt. It's okay. Come on, guys, from yesterday. Those of you that are stuck, it's okay. But ew, fractions. What do we do when we have ew fractions? No. Some of you are a little confused with how it's written, so it's okay. Let me write it like this. Some of you are confused with how it's written. This is how it would have been written yesterday. I would have had this is the problem, and then this is our work. Keep going. I'm just trying to jog your memory a little bit. Anybody do A, B, and CX plus D? Nice. Those of you that didn't, it's okay. You just have to hold your bike a little bit longer. But let it go sometime. It's okay. They need theme music for the problem. Elevator music puts me to sleep. Won't lie.
No, I'm sorry.
We could do some, what's that new genre? Is it like electric swing or something like that?
Yes.
That'd be cool. That'd be nice. But right now, here's the problem. I need you guys to actually be getting it, which some of you are, but some of you aren't. Groups, really quickly, turn, collaborate. It's okay, turn and collaborate, Leo. Get some ideas. Exactly. That's exactly what you want to do. Remember, we got to get rid of the denominators. Multiply everybody by him. We'll cancel, some of it will stay. Remember? Multiply everybody by that denominator. If you want to do it. But my mind says, oh, gross, an x cubed and a squared and an x. There's so many equations. I would do the zeros way. You get to make a choice, but I think the zeros way will be easier. No, remember the zeros way is you choose some of the zeros from up here. So maybe you choose -2, maybe +2, and then maybe a few other convenient ones like 0 and 1. You can do the foiling out. It would just be messy. Christine, does it make sense what they did? If you want to. Well, I would say leave the A out so you can show what's left. The x plus 2 cancels with that guy, right? So you're going to have those two written. The problem is you're going to have to do that for every single one. I would write it all out, then go. And remember, x squared's on this side. Because for him, all of those cancel, and he's left, and then equals. And then A gets multiplied. B gets multiplied. CX plus D gets multiplied. Like looking Does that make sense? Does that make sense? Okay. Kiddos, check out people in your group, and if you are someone who can be encouraging to someone who's stuck, encourage them to keep going. If you're the one who's stuck, listen to the ones trying to encourage you. Keep going. There you go. Good job, encourager. I was waiting for that. Just say learn from your mistakes. No, you're not, Abby. Can I pause everybody for 1 second? Eyes on me. 1, 2, 3. There you go. 1, 2, 3, eyes on me. 1, 2. Thank you. So, coming back. Don't we have 2 routes that we can take? Routes, it depends on where you're going. 2 ways that we can go. One way, it was the left way from yesterday, color coding, says, okay, let's multiply all of that out. Exactly, I agree. Now, yesterday it was easier, I think. Most of us were like, it was easier to multiply it out and take the squareds, take the singles, take the constants. Go. Problem is, what are you going to have this time? Ugh, you're going to have cubes and squareds and singles and constants. Could you multiply it all out and set 0x cubed equal to all the cubes? And 1x squared equal to all the x squareds? And 0x equal to all the x's? And 0 equal to, okay. What's the other, which I think is easier on this problem? Set the zeros, plug the zeros in. Can anybody see any x values that would be a good idea to plug in from the denominator? 2 would be a great one, because that would be a 0. What else? -2, that'd be a great one, because it's a 0. Imaginary. How many unknowns do we have? Okay, so we have -2 and 2. Let's pick some convenient ones. What are some easy numbers that are nice? Yeah, 0 and 1. Okay. Sorry, I picked you up, some of you. You were on the ground. I was, okay, whoosh. Start again. Go. Go. If you want to foil, go ahead. Go ahead. If you did, go ahead. It'll work. If you didn't, I think this way is easier. Ba-dum-bum. Next time use just the foiled again. Oh. That one's good. Anybody seeing why that -2 is nice? No? And a lot of stuff cancels when you plug in, right? Yeah, it does. For 0 and 1. -2 and 2, I looked at the factors, and x plus 2, x minus 2, I stole their zeros. Because it makes life so nice. Because check it, Nick. Because this is a 0 of that guy, when I plug in, that's going to be like a value. But that's going to be 0. That's going to be 0. So I choose zeros if I can. Same thing will happen here. 0. 0, so I'm just going to have this. But then I was like, I ran out because his zeros are imaginary. So I said, all right, something easy. 0, 1. Make sense? Yeah, so I take this whole expression, I plug him in. Which seems awful, but check it, Leo. If I plug in, that's going to be negative 2 squared is 4, right? Negative 2, okay, so A times negative 2 minus 2. 4 plus 2 is 6. You're like, this is going to be awful, but check it. Since it's a 0, if I plug in negative 2 plus 2, 0. If I plug in negative 2 plus 2, 0. Oh, I got it. You see it? And then plug A in, now go again. Does that make sense? Good. Has anybody gotten negative 1/6 for A? Is it making sense even though you're not writing it?
Yeah.
Mari, it's making sense?
Yeah.
I know, you just like to.
I'm a G. Wait, where'd the 4 come from? It's squared, yeah. Got it. Understood.
Well, check it. If I plug in negative 2 plus 2, the whole joy of plugging in a 0 is if one thing's 0, the whole thing's 0 when you multiply. If one thing's 0, the whole thing's 0 when you multiply. That's when you plug in negative 2 plus 2, 0. The whole thing is 0 when you multiply. Negative 2 plus 2, 0. The whole thing is 0 when you multiply. Ooh, yeah. Now I can say because of this guy, let's change him now to be a negative 1/6. Yeah. Oh. Wait. Positive 4 plus 2. Guys, on the next one, 2 minus 2 is 0. The whole thing's 0. Oh, that's not 0. Okay, plug in. All right. This one, check it. You could start plugging in, but what's going to happen right here when you 2 is 0? It's using the thumb trick idea, just we can't go straight to an answer, but we can use the idea. Plugging in the zeros sure does help. Yeah, you got it? Positive, right?
Yes.
Yeah. Write down as many numbers as you need. There's no shame. Like, you don't have to keep it all in your head. You seeing it? Nice. Whenever we have what I call an irreducible quadratic, basically a quadratic that can't factor down anymore. Partial fraction is built on the idea that these are all little baby proper pieces that combine to be this proper fraction. If it's improper, we divide. So to be proper, the degree on top has to be 1 less than the degree on bottom. If it was tied or higher, it's improper. So 1 degree less than a first degree, x to the first, is x to the 0. So I don't write anything. But 1 degree less than a squared is a single. So I have to put like a little linear equation up here just to say, you know what, it could have been up to this. If it was any higher, like the degree was any higher, it'd be improper, it wouldn't be there. If it was x cubed, this would be cx squared plus dx plus e. I just don't give you guys any of that hard, so I haven't shown it to you. But yeah, Jacob. There could be. I mean, I probably won't give you one that's hard in multiple ways. So if there is an improper one, hopefully its partial fraction will be kind of nice, if that makes sense. But there definitely could be an improper one where I need to see that you know divide first. But just take it one step at a time. Yeah. You can do this for every problem. Just, Leo, sometimes, like you see here, you run out of zeros, so you just have to pick those other numbers.
Everybody shuts down. Everybody sits down.
Well, because I'm still missing these two guys. So I need to keep going. Yeah. And I said, what's super easy to plug in? 0. Michael, what's up, bud?
So when you plug in 0, do you plug it into that x plus the c plus d?
Yeah, plug it in everywhere. Everywhere, everywhere. 0 plus 2, 0 plus 2.
You're right. Right before the equals 0.
Michael's question was, when you plug in the x, do you have to plug it in next to the c also? And the answer is definitely. C times 0 is going to be 0. That's why it cancels out.
D is 0?
D is not 0 because a negative times a negative is a positive. These are going to combine. So it's going to be 0 equals 10/6, which is just, what, 5/3? No. 8/6, sorry, which is 4/3. Subtract the 4/3, negative 4. I think it's going to be a 1/3. Anybody get there before me?
Yeah.
I think it's a 1/3. Yeah, you have to divide by 4, which cancels with the 4. Like, subtract it, then you divide by negative 4, the 4's cancel. Yeah, Leo, what's up? Yeah. Yeah, you could. The reason I didn't, I started to. Then I saw that 2 minus 2 was 0. I'm like, well, forget it. The whole thing is 0. But yeah, you could. Exactly. All right. Has anybody gotten through the last one to get C? Okay. Plug in 1. 1 is equal to negative 1/6. Negative 1 times 3. C times 1 is C, plus 1/3 is D, times 3 times negative 1. A lot of numbers, but we're right there, guys. You see it, right? We're close. 1/2. It's going to be 3/2. Distribute that in. I think that's right. Hey, 2 minus 2 is 0. 0 divided by negative 3 is?
Okay, I got it.
This makes sense. This is comprehensible. I'm just writing down 1.
Yeah. Did you get it? Wait.
So we found them all.
Hold on, something funny happened. This is D. This is D. Hold on. A negative over a negative will be a positive, so change that first. The 4's cancel to be 1/3. Yeah, you just get 1/3 left over. But I think somehow your letters switched. That one's D.
Oh, it's D.
Yeah, somehow your letters switched. Do you,
I put that for C.
yeah, I know. How'd you?
Wait, why do you have to find D?
Oh, that's what's wrong. Yeah. I think what you... Go back up, Leo. This one's a squared. Nick was just asking me that, which means this partial fraction can't just be a C. It has to be a C. It's squared. I have to make this a little bit bigger. And that's something. Yeah. So when you solved for your C, you were finding this guy. There's just another guy you have to also find.
Okay, so for me, I put C.
Yeah. So you only got like part of the answer.
Why would you put CX plus D?
Because of that little squared on the inside. That's what you always do when there's a squared on the
Is that like a
yeah. Hey guys, A ends up being negative 1/6, right?
Yes.
B ends up being 1/6.
1/6.
Now, okay, let's quiet on down. Shh. Some of you are still getting there. Some of you have gotten there with me. Some of you beat me and got there. Some of you would have accidentally not been thinking and just put a big old C above this guy. And ironically, in this problem, since the C ends up being 0, you actually would have been okay. But here's the dilemma. You think C always ends up being 0? No. So even though it would have been okay in this problem, the dilemma is in the next problem where maybe C ends up being 2, you're going to get all messed up and not even realize that you didn't finish. Okay? So whenever you have, once again, a quadratic, we call it irreducible because you can't factor him down into like nice little linear guys. Whenever you have a quadratic, according to our notes, we said whenever there's a quadratic factor that we can't go further on, you've got to put either ax plus b or cx plus d or ex plus f, whatever. You have to make a little linear guy on top. That's right. So how on earth did the book get to 1/6 times negative 1 over x plus 2 1 over minus 2 plus 2 over x squared plus 2? Which ones make sense? Yeah, right? You take out the 6th, you take out the 6th. How did they take out a 6th? Because what is 1/3? They took out the 6th and left the 2. I know that this looks really complicated if you just look at it. And I know that some of you guys were totally overwhelmed when I showed you this. But pause. Do you understand the steps? The answer key can look horrible sometimes. But do you understand the steps? Leo, go ahead. Yeah. It actually ended up being okay because remember how this whole thing became 0 in both? So it actually didn't matter that you were off on that because it was just 0 anyway. So my 0 was your 0 and it didn't change anything. Does that make sense? And then for your last one on mine, that ended up canceling. So your little c by itself is like my little d. So that didn't mess it up either on your last answer. So that's why you happen to be just fine and you totally forgot about him because the didn't matter. Another one it might matter. All right, cool kids. So with that, it looked awful, but does it now look at least possible?
Yes.
Comprehensible. We'll take it. Maybe with a little bit of work, but still. So then looking at the answer key, all of that was to say, hey, guess what? This isn't just right, but it hopefully makes a little bit of sense. Okay? We still have a few more evens, but nice thing is they're a little bit nicer. Like, for instance, number 44, some of you might have thought it was disgusting. Some of you might have forgotten that it was improper. Remember, fractions are improper whenever the degree on top is higher or equal to. So then after doing, Well, here's why, but hold on, pause. I'm not up there yet. But AJ, she's a little bit ahead. Since the degrees are equal, you divide. When you divide, you get here. Why did they not break him down? He's a proper fraction. They should have broken him down, right? AJ's like, how'd they just leave it? It's time to do partial fractions with that guy. Ooh. Isn't this going to be negative 23? You can't factor, and if you can't factor, you can't break it up, and if you can't break it up, you're done. It doesn't have any parts. It is what it is. It's irreducible with its cx plus d already there. Fine, I'm done. Nothing else to do. Does that make sense, AJ? Cool. It was so easy, it was hard. Done. All right, kiddos, any odds we got stuck on? 27? 31? Okay. Silly kid. I'm going to peek really quickly at 27 and 31. I might not finish it. Shh. I might not finish them, but I will at least go ahead and give you guys a clue. Because I think the process, I mean, if you guys were able to do that crazy hard one, you should know the process for easier ones. That doesn't mean that you didn't get stuck, though. So hold on. 27 and 31, let's just make sure you guys know how to start them. And then if you guys want me to, with the extra time, to come check your individual work, we can, okay? So 27 and 31, let me do single page, and here we go. Awkward. We're still going. Okay. I think the whole job was just get partial fractions, right? My guys with directions really quickly, partial fractions, yeah? Okay. I'm getting rid of this guy because you guys, I don't think, had 29, or at least you didn't have a question on him. White marker. Looks great, though, huh? Okay. How many partial fractions? Because I have to, whenever I have a squared, I have to do a single and count up. What's my unknowns? Linear. Now, some of you are like, okay, so bx plus c? No. The squared is on the outside. The squared's on the inside, then I get to just use my normal b. Ew, fractions! What would you do? Shh. Entertaining, as long as he's good. We're good. Coming back. Multiply both sides by the denominator. And then either use your collect the terms and distribute, or your plug in the zeros and other convenient values. You guys know how to keep going at least, right? What would you do with this guy? Not improper. Don't divide. Factor out the x in the bottom. You end up with, let's see, that would be x times x squared plus 1. Hey, x squared plus 1, can I go any further in my factoring? No, it's irreducible. So, eyes on me. Some of you guys didn't know this coming into the example. How do I make partial fractions for these two guys? Who's on top? Good. Who's here? And what's on top? You need, see, whenever that little quadratic is stuck, I need the bx plus c. Yeah.
For the top one,
yeah.
Or, well, I guess for both, you would only need two.
You only need 2 zeros if you're going that route, but this one you need
3.
Yeah. This one, you have 1 0, right? 3. Use him, but then, okay, well, I need one more, so use maybe x equals 0. That's fast. This one, you have 0. Use him. Maybe -1, +1. And remember, you can be using 17, but who wants to plug in 17? Not this girl. Okay, so that's 2731. If you guys need me to check your work, we definitely can. I want you guys in your notes really quickly. 7-5. Let's go over any there's one little detail I need to finish, and then we're done. 7-1. One tiny detail. You guys did have a lot of questions in 7-4, but that's okay. We got you, I think, without me holding the bike the whole time, somewhat through a really hard problem, and I hope that helped. But 7-5, we left off right here yesterday. I know it looks gross. Usually I get out the highlighters in the program. It just didn't have time yesterday. But do you get the idea of we had to graph 3 different equations. One of them we had to get y by itself to even graph it because it was a line kind of hidden. Standard form, bleh. Slope-intercept form, so much nicer. We had some dotted, some solid. We talked about that yesterday. Shading. The trickiest one was this guy, because it was a straight up and down line. But where did we shade if x is greater than -2? -2.
To the right.
Yeah, because all of these x's, -1, 5, 10, 100, those are all greater than. So we shaded to the right and we said, okay, where does the green and the blue and the red all intersect? And the blue and the green and the red all intersected right here. I use a third color because I sometimes get a little bit lost like some of you did in my graph yesterday. But here's the dilemma, kiddos. There's one thing we didn't consider. Vertices. Okay. But vertices, didn't I just say corners? There's a corner. There's a corner. And there's a corner. Now, here's the weird thing. I'm not making it empty to show you, hey, there it is, little spotlight. I'm showing you empty because that's technically what the graph would need. Why empty? This is just a recreation, looks a lot prettier. Hey, look, there it is, here it is. Okay. Why am I showing you empty circles? This guy says can be there. This guy says can't. If I put the two together, well, if one can and one can't, if they're going to be together, we better not do it. Can't. This guy can, can't. Okay, can't. This guy can't, okay, can't. It's a little hole saying it's a boundary, it's a vertex, but it's not technically allowed to be there. And how'd they find the vertices? If they graphed really nicely, couldn't they just kind of count and see them? If they didn't graph nicely, how could you have found this guy? Well, wouldn't you have found the intersection between green and blue? And green and blue, well, hold on. Blue said y was 3. Okay, cool. Green says x is 2. Okay, cool. This guy would be the intersection between, wait, what two graphs? Red and green, right? Okay, cool. So red and green. Green says x is -2. Red, okay. Take the green x, plug it in. -2. I need to go ahead and add that. That'd be 4. Divide by a negative. -4. And last but not least, we've done green and blue. We've done red and green. Don't we just need red and blue? Red and blue. Blue. Oh, cool. Y is 3. Remember, we're treating these like little baby equations for our boundary lines. So y is 3. Plug it in. 3 plus 2 is 5. And if the equations were harder, we'd just actually do the work of solving the little baby system for the intersections, like we've been doing in 7-1, 7-2, 7-3. Otherwise, the boundary is just that solid because he's solid, dotted because that side was dotted, and dotted because that side was dotted. Do the vertices make sense how to find them?
Yes.
Figure out who's intersecting, go put those two together, and find the points of intersection. Jacob.
So is your answer the graph, or is your answer the...
Depending on what they ask, it could be both. If they just say to graph the system, done. If they say to graph and find the vertices, or just find the vertices, then maybe you'd have to keep going and find the points. Exactly, because you might have to do little baby systems to put them together. Well, 7.4 is partial fractions, which as a whole applies to calculus, but you needed systems to solve. So 7.4 said, let's use 7.1, 2, and 3. 7.5 says, let's use 1, 2, and 3. 7.4 and 7.5 are applications or using the math that you built in 7.1, 2, and 3. Does that make sense? 7.6 would have as well, but remember, we're not doing that one. Kiddos, here is homework for 7.4. Oh, should have that done. 7.5, the shading one, with, oh, hey, let's review. Go, team. Oh, I didn't make you do a 7.3. I'm nice. We're skipping 7.6 altogether, but some of you, if you did 7.5 last night, which to be honest, we almost could have, maybe you want to write down the review. Guys, in the last minute of class, get down whatever homework assignment you need to work on next. Tonight, 7.5 shouldn't take you a lot of time. Have those colors handy. It'll be nice. Or those, sorry, Chris, different shades of something. Yeah. Ready? And if you can, start on the review, because tomorrow I would love to say, anyone start the review and have questions that I can answer. That'd be great. Otherwise, we'll mostly have a work period. AJ. There's a mission meeting today during lunch in my room. I will. I just won't be super available unless you get me right at the beginning. If it's right at the beginning. If you want to come in here and hang out, it's cool. I just can't answer questions. All right. Anybody else need to write down any homework? Go ahead and do so. I am pausing the video because